Airflow is one of the workflow managers that you can use for orchestrating your workflows in the cloud to process different kinds of data pipelines, from machine learning to processing any kind of batch data, and it's used by hundreds of different companies. It's really popular, and its popularity is also because it's Python. All of it is Python. So you write the DAGs, the directed acyclic graphs of the pipelines. You write them in Python. You don't write any XML code, God forbid, nor YAML files. You just write Python code. And this means that you can model your workflows in code. So you can be a developer and still model your workflows, and actually you can have fun while doing it. And this is quite powerful part of the language. Few words about myself. I'm a principal software engineer at Polydia. It's a software house in Warsaw. I am right now an Apache Airflow committer. I started to work with Apache more than a year ago, and after half a year, I was asked to become a committer, and I agreed, of course. I'm a certified Google Cloud Platform architect. I'm an ex-Googler. I used to be tech lead manager at Google. I'm an ex-CTO. I used to be a CTO in my own company, but now I am still in the same company, but I switched back to engineering because that's what I love. And I have other people who manage the company. I recommend that, definitely. And I'm ex-choir member as well. I just, I sang 30 years in a choir, more or less. Yeah. 30 years, yeah, that tells something about my age. A few more words about Polydia. We develop Airflow. It's one of the things that we do in Polydia. So like we have a team that develops Airflow, but it's only part of what we do. Polydia is a software house traditionally or historically coming from mobile app development. And few years back, we started to work on cloud, on infrastructure tools, as well as IoT devices. We have 70 people, hundreds of projects delivered. We have plenty of projects through referrals, which probably means that we do a very good job because our customers like what we do and tell other customers that they should work with us. And I don't know where the number came from, but we have more than 3 million users of our applications. I'm not sure if it's true. It's like, probably it's a bullshit, but. That's the team. That's the extended team. So we've worked over more than a year now. We've worked on Airflow, and we are super lucky that our customers pay us for working on open source software. And because Airflow is an Apache Software Foundation project, it's an open software. Lots of people are committing to Airflow and they are not paid for that. We are, and that's an amazing thing. And over the more than a year, we had like 8 people working on it. Right now we have a team of 5 people, the top people here, and Tomek is actually sitting at the back, so he's another team member of ours. And three more people did work in our project but don't work anymore. And this means that our project evolved. How it evolved? In August 2018, we started with just 2 people. Right now we have 5 people, overall 8 people. And I put that slide in because we had rebranding of our company recently. And this slide was so cool that I decided to put it there. Yeah? So it doesn't have any other meaning. Yeah? What we were supposed to do. When we started the project, we started with developing operators, so-called operators for Airflow. Airflow is basically a conductor or orchestrator for different kinds of workflows, and it communicates with a number of external tools. Apache Kafka, Google Cloud Storage, you name it. All the different things that you can communicate with and tell the data to go from one place to another, or aggregate the data, or do whatever with the data, then you can have an Airflow operator developed for that particular service. And we developed hundreds of them over the year. That seems quite a lot. We worked with different Google Cloud Platform services. So we worked with more than 18 Google Cloud Platform services. And we also developed a tool. Are you familiar with Uzi? Maybe somebody did Uzi? I see some sad faces there. Yes, yes. So if you are using still Uzi and you want to get out, we've developed an open source Uzi to Airflow converter that can convert the XML workflows from Uzi to very nice and readable code, Python code from Airflow, which is actually cool. It works. And here is a little thing that I wrote a blog post recently about it's a breeze to develop Apache Airflow, about exactly what I'm talking about today, but with a little bit more context. So if you want to go and read a little bit more context, there is a quite long blog post explaining why we developed Breeze. I will tell about Breeze during this talk today. And to summarize it very quickly, like whenever I join any project, whenever I start any project, my idea is that whenever we finish that project, we should be 10 times more productive than when we started it. So like we shouldn't really just continue doing what we did at the very beginning, but we should find all the places that we can improve our work so that our customer is happy, so that we don't do boring job, so we don't do repetitive job. So we basically automate everything we can and make it super easy to work. And this was our goal when the team started, because we not only delivered what was asked from us, so we didn't only deliver those 100 operators that we should deliver, but we delivered, thanks to the time that we freed because we improved our productivity along the way, we delivered extra something more. So we have now 2 Apache Airflow committers, myself and one of the team members. We improved a lot documentation of Apache Airflow, which is now being improved even more. We developed Breeze, few things about it later. We helped with moving Airflow from Python 2 to Python 3, or kind of abandoned Python 3 in the new version, like pretty much every other project is doing right now. We've implemented PyLint compatibility. We are implementing it. It's still in progress. I re-implemented completely the way how CI environment works. And we've implemented, that's the coolest stuff. I will not talk about this today, but this is the coolest stuff we've done, because we developed these 100 operators because at the end we ended up with the generator. So the operators are generated for us. We just tell which service we want to have an operator for, and it's automatically generated. All the code is generated automatically. And that's super cool, but I will not talk about this today. I will talk about Breeze. There will be another talk about that. Just look around. Some people from our company maybe will talk about this operator scaffolding, which is actually pretty cool stuff. So what was the problem? Initially when we started the project, we realized how difficult it is to join the project, how difficult it is to start contributing to it. It has a lot of tests, and that was actually pretty cool, because we had like 4,000 tests running, but those tests are unit tests, system tests, integration tests, you name it. They are a bunch of tests to run, and they are running on Travis CI. And if you can take a closer look at this picture, it takes quite long to actually execute them. Yeah, it's like 20, 30 minutes to run the tests. Plus we have a number of static checks and other stuff. And the problem, we had to test with different backends. Airflow has either Postgres or MySQL or SQLite as a database. And surprisingly, not everything works the same with those databases, even though we use SQL Alchemy. We had multiple Python versions. When we started, it was 2.7, 3.5, 3.6. Now, in the old version, which we still support, we still have 2.7, and the new version, we have to support 3.7. And surprisingly, there will be another talk about that. There are big differences even between Python 3.5 and 3.6, if you don't realize that. And we stumbled upon a number of problems because of that. So we basically have to make sure that it works on all those different environments. We have different executors, local, sequential, Kubernetes executor, and a number of other options. We have automated static code analysis, which takes quite long because Airflow is quite a big project, so it takes several minutes to run static code analysis on it. And we have automated documentation building. So we improved the documentation because most of it generated, but now it generates 10 minutes because it has to parse all the files and do all the pre-processing in Sphinx. So it takes quite a lot of time. And the problem is that Travis is slow, and we have limited number of resources because it's an open source project, so we don't have paid account, and we have to wait sometimes hours before the code is committed and the tests are executed, like literally several hours. Yeah, that's a big problem. So, okay, so then you would think, okay, let's run the tests locally. The problem was when we joined the project that it took maybe 5 to 6 days, really, to have an environment that you could feel comfortable with, because it was so complex and convoluted how to set up this environment. So really, as a fresh developers, you'd have really big frustrations to understand what's going on. It was very, very complex setup involving Docker, Tox, several Python versions, Docker Compose, and a number of other things which were kind of, it took me days to understand how it actually works, and to make it work, it was even more complex. So there was a high learning curve to learn how to work with it, and especially it was very slow to iterate, because the whole integration, the whole system was complex, and it was really not meant to be run for single individual tests. It was meant to run the whole suite of tests on Travis, but just running single test and iterate on that in the same environment that Travis has was fairly complex. Yeah, that's the thing. So like scripts were only designed for CI. For whatever reason, every time you started to run one test, all dependencies were reinstalled from the scratch. Whatever reason, that was the kind of setup, because on CI it makes sense. Like install environment, run all the tests. But for individual tests, you wouldn't really want to wait few minutes or 10 minutes initially, or 15 actually. Well, it was close to 20 when I started, to get your test run, yeah? So that wasn't really good. Always the database was reset first time, every time you use it. And it's like, what? Like, I mean, the test run 20 milliseconds, but the whole setup takes 2 minutes or 30 seconds more. That's not really good for iteration speed. And it wasn't really easy to understand what to do in order to cut that time. So it took minutes to run one test. That's not really acceptable. And it was not explained, or nobody was guided, or the new person wasn't guided how to run and iterate with the tests. So my personal goal always is, like, especially when I joined this fantastic open source community as Airflow is, to bring more people to contribute to the project, because that's the whole power of community. You can have people just contributing the code, and the problem was that actually new people had a lot of trouble and frustrations. They couldn't really start very quickly. So my personal goal was to get new developer coming and in less than 10 minutes have an environment which was ready to use for that developer, and that this developer knows how to iterate quickly. Challenge accepted. Half a year later, no, joking aside. So what was the focus? Focus on developer productivity. This was always my goal. A faster development cycle, decreasing frustration, guiding the user, improving the teamwork as well. One of the problems which we noticed, as usual, was that we had a big team of people, and it was changing. And the challenge was to keep the environment synchronized between them. Of course, Docker is a good solution for that, but Docker on its own is not enough. So we had to figure out a way how our developers can share the data between them, share the environment, the working environment. Yeah, and as I mentioned, easy for ad hoc contributors to code and test very quickly. So half a year later, now it comes to that. It really literally took half a year to go through this process. First, to become a committer. Secondly, to convince people that you need to implement the change. Then we developed our own change. Then we had to make it in a reusable way for all the community, etc. Lots of comments. Actually, my PR, one of the 4 PRs that pull requests that I implemented, was the most commented PR ever for Airflow. Like, we had 258 comments, I think, or something like that, close to that. And actually, I cheated a bit, because when I was about to merge this PR, I just missed like 2 or 3 comments to be the most commented PR, and I asked a few people to add their comments. Yeah? But now there is. It's the most commented one. So I had to first implement the multi-layered and multi-stage official image for Airflow, which wasn't there. The image was like super difficult to manage and to update. The simplified development workflow, that's the breeze that I'm talking about. Now I'm working also as a spin-off from that. We are migrating out of Travis because it frustrates us a lot. And at the end is something that we are going to implement still, and that's still in progress to support automated system tests. So that, for example, with Google Cloud Platform, you can run all the tests automatically using the actual Google Cloud Platform. Yeah, right now, those tests are mocked in many places, but you never know if they actually work because the API could have changed. So we are going to automate this part, but that's a, let's say, later stage. So out of that, 2 of them are done already. Still few corrections which are on the way. Migrating out of Travis, this is in progress, and support for system tests, that's coming. So, there are 3 types of environment that you can work with in Airflow. You can have local virtual env, which allows you to run basic unit tests. You have the Travis fork that you can run your tests on Travis, but again, you have to wait a long time. And you can have Docker composed local environment that you just spin off automatically. And this is the part that actually I improved significantly, because initially it was only meant to be run on Travis, not for local development. So, quick movie about the developer experience. This was a developer experience with the original version of the environment. This movie is actually 20 times speed. So this is what was happening when you try to run single test on Airflow a few months ago. When it's still running. And at the end you have an error and the environment is stopped and you have to rerun it again from the scratch because something was wrong. Yeah? Basically, that was the first time developer experience to run a test. Not very convenient. So, okay, I won't run it again. Hopefully. Sorry. So total time of execution of that was 7 minutes to run one test. At the end, you got a failure. If you actually manage it to run it, you had to wait 10 to 20 seconds to rerun single test. That was the default behavior, and it wasn't easy to find out how to do it otherwise. When you re-enter the environment because you killed the Docker or you restarted your machine or whatever, again, the same time, 7 minutes to start it up, and most likely you will get an error. You couldn't have a bash history. It wasn't retained across sessions. So, what? Okay, let me just continue with that. So, I've implemented several stages. The improvement I've implemented in several stages. So first of all, we have images which are automatically built whenever we push the code. And it's incrementally built image, so it doesn't rebuild all the time from the scratch, but it only rebuilds what is needed. And it's highly optimized to only optimize the latest layers. When you want to build and run the environment locally, first thing that you do, it automatically downloads and sets up all the environment for you or the Docker images. You don't have to worry about that. They will be downloaded automatically in the right version, and they will be updated automatically whenever needed. So all the tests and static checks are run using Docker Compose and Docker environment, which makes it now easy, because it wasn't like that before. Previously, we used a mixture of Docker Compose tests and static checks run on the host machine on Travis. That was like fairly complex. And now, when we moved everything to Docker, we can very easily move it to another CI system. We are working on GitLab CI move or GitHub Actions. We will see which one will be better. So we are now CI system independent. Now, you have a number of scripts now. That was the second stage. It was not yet the final version. So there are a number of scripts that automate a lot of work for you. It just starts the environment and you tell which version to use, which backend to use, which Docker image to use, which environment to use. You can run all the static checks. We have a lot of static checks, MyPy, Pylint, Flake, checking licenses, building documentation. This is all like bash scripts. And yes, it's all in bash. I mean, yeah, that's kind of good. And you can automatically update images as well. So you have a script to update you to the latest image. Images, because we use several of those. Another stage, or step 3, implemented was just a very simple to use and automated script to run single tests. So you enter the environment, you just run test. It works out of the box. It initializes the database only when needed. When you run it for the second and third time, it will not reinitialize the database, and it will do it automatically. All the environment variables are set, which wasn't easy before, because you had to manually set a number of environment variables. You have really sub-second test overhead. And actually, you have an explanation how to debug it. If you use IPDB for debugging, it actually tells you exactly, guides you. And this is another thing, this is another thing that I put as part of the environment. All the scripts and all the mechanism that I use, they are guiding the user. They are helping. They are providing additional information how to use and do stuff. For example, in this case, they tell you how to debug. It wasn't easy because normally you would ask how to debug, and then you would go to Slack or somewhere, or Stack Overflow. And now it just tells you how to do that. And you can have verbose output, which is the same as you have in the Travis. Now, this was the intermediate step. You have some scripts. You have to remember which scripts to run. Okay, but then the name Breeze came. Yeah, you can see the parallel. Yeah, it's a breeze to develop Airflow. You see the breeze flowing. It's something that you would want to see, just sit there and get the breeze flowing. So this was the cool name that actually I invented, and it's been approved. People like it as well. I'm super happy about that. So what I really ended up with is I call it Swiss Army knife of testing for Airflow. So basically, there is one script, Breeze. Well, what else? And then you can just run it with whatever parameters you want, like SQLite, database, Python. You can use it to run static checks as well. It remembers the state that you are in. So if you used Python 2.7 environment, when you re-enter that, it will remember that. It will manage your images automatically. When you run it, it will see that the image is outdated. It will tell you, please update your image. Or maybe you don't want to do it now. You can continue doing as you do, but remember to update it, and next time it will ask you again. All the options are autocompletable. Yeah, we do like to press tab and have autocomplete. Who doesn't? Who likes to use autocomplete in their CLI tools? I do, and some people do. So this works out of the box. Again, sub-second test execution overhead. You have the sources mounted automatically to the Docker. That's the typical case that you do for Docker development workflow. So whenever you change it in your IDE in your host, you can run the tests inside the Docker environment, which is running, of course. You have ports forwarded. You can actually connect to the database that is in there using IntelliJ, PyCharm, whatever database you have. And these ports are there, and there is an explanation how to do that. There is a URL that is actually used to go there. And there are multiple hints on how you can test, how you can run it, something that you can actually even turn off if you want, because you are an experienced developer, so you can permanently turn it off if you want. But initially you have those hints. Plus some extras. For me, I always forgot what is the test I'm going to run, which package it has. There are a number of those. So autocomplete works inside also now for tests. So you just start typing the package name, and autocomplete will help you if you try to run it. There is a history of in Bash. Fantastic. Yeah? I never remember the thing that I did last time, but I can just use an arrow. You can run static checks automatically, those MyPy, PyLint and stuff. It's also done using the same environment. You don't have to set up anything else. You just run it, and it works. There is a way, including screenshots, explaining how to debug using your IDE. So, IntelliJ, especially the paid version, actually has this super cool remote debugging feature, and you can connect to your running tests or running Airflow and debug it from the IDE inside Docker Compose, which is cool. And we implemented something on top of it, which is pre-commit checks, which I'm going to tell about at the end. So, and the most important of all, our designer, because our company is a mobile application development company as well. We have designers design this super cool logo. So we have a logo for Airflow Breeze as well. And Milka, she's Finnish. She was super happy when this was finally merged 3 weeks ago. Yeah? And yeah, it's official. So there are some goodies of Breeze that I'm gonna explain while I play the short video. So when you run test for the first time, you just enter Breeze. You know, as you imagine, you choose the backend and Python version. It starts the environment. By the way, this movie is not sped up in any way. It just works. Yeah, it's like the native speed. So now you execute the test, and the database gets initialized. It takes a little time, as you see. Yeah, the database is created, initialized, the test is run, we have 5 tests to run, and they will finish very, very shortly. It's a movie, so no worries, it will. Yeah. So now, whenever you try to run the same test, iterate on that. You fix the test, and you want to rerun it because it failed last time. You just do the same command, you don't modify anything whatsoever, you just run the test, and well, yeah, it starts running immediately, no database initialization. But you can force the database initialization if you want, there is a switch for that. Yeah. But it's just super easy for, nobody has to know about this. Yeah, you just run it and it works. It just works, yeah, like Apple computers, which is not the case anymore actually. Yeah? They don't just work. Yeah, so we have this fantastic test autocomplete. As I said, we have more than 3,600 tests, I think, right now. We will see the number in the moment. It's not all, but you will see some subset of those. But then when you type autocomplete, you will see all those possibilities, and you can, just as the usual, autocomplete works. Yeah, you just can choose which test you want to run. And by the way, I never know with nose test which colon or dot should be in which place, because it makes no sense whatsoever. Yeah, so that's when you run the test, and you can reinitialize the database if you need. It's super simple, just another switch, which, by the way, is also autocompletable, as you see. I didn't type that fast. And then it will actually restart and reinitialize the database, which sometimes you need in order to run some tests. You want to have a clean database state when you run the tests. So that works. Is it all? No, we still have something. So you can actually see the hints for the developer. So you run the Breeze, and what you see, I'm just scrolling it back. You see all the information about the environment, which Python version you used, which database you use, which Kubernetes version you are using. You can see some additional information, how you can run some commands. You can see how you can add Breeze to your path. And by the way, this comment will disappear if Breeze is actually on your path. Then you see port forwarding, which I mentioned. So you see URLs of the database connection that you use. And it's just one command to set up autocomplete for you, so that all these options that Breeze has are autocompletable. And you can disable all of that as well. So that's pretty much it when it comes to debugging. It shows you actually how to do debugging as well. So going back, there are some additional sources because we also developed a lot of documentation. So we have for now, there is a Breeze intro which I developed or I recorded, and we have which is like less than 10 minutes introduction to how to develop. And we run with one of the committers, one of the other committers for Airflow, Ash Berlin-Taylor from London. We ran a webinar where we recorded, and you can actually take a look at that as well. Some features, images are automatically managed. We have pre-commit checks, which is almost all merged. I will tell about pre-commits in a moment. We can run tests with or without database initialization. We have full Travis CI integration, comprehensive documentation. Documentation looks like that. It's fairly straightforward and focused on the tasks that you are supposed to do. So it is really focused on, like, if you want to do something, it will explain you what to do. They have some screenshots. And Breeze was just a start. So we had a number of spin-offs. And one of the spin-offs there is our pre-commit checks. I don't know who used pre-commit checks, pre-commit hooks so far. I haven't used it for a long time because I thought it's super difficult to manage and, you know, share with the team. But we found this in the Untitled Airflow project. Actually, we found this fantastic precommit.com project. If you are developing on Python and you don't use it simply, because it's super cool. Because actually it manages all the hooks, Git hooks, commit hooks, and push hooks for you. And you can commit single file, XML file that describes all the hooks that you have, and every committer or every person who uses the same project can just run pre-commit install, and that's it. And then the code is actually checked for many things. I mean, depends how many you configure before it actually gets committed, and it's super powerful, and it makes your iteration speed much faster. So it's super easy to use. Just run pre-commit install and it works. Then you can also run pre-commit run and run it without trying to commit. So it has a very good and nice CLI. You can just run one of those checks. You can run it on all files if you want, if you have 10 minutes of free time in our case, because it takes as much right now. But by default, it runs only on the files that you actually changed in your commit, so it will be very super fast, actually. It catches error early, like as early in the development stage as possible, when you try to commit it. That's super cool. And it makes committers' time more efficient because we don't have to review the code for all the things that we have here. And you can see what we have even more now, but we check if licenses are okay, if tabs are not committed to the code, because we are in the no tab camp, yeah? Remember, I mean, who is using tabs in their code? That's good, because GitHub stats tell that people who use tabs earn less than people who don't use tabs for developers. So remember that, don't use tabs. So we checked if there are actually no tabs in our code. We check if we haven't committed something by accident, like private keys or unmerged change. And by the way, pretty much all of those checks are there. Somebody developed it already. You just use it. You just specify what kind of checks you run, and that's it. You don't have to develop it yourself. Fixing end of files, mixed light endings, linting XML, linting YAML files, checking shell scripts. This is the biggest, I'm a big shell fan. I mean, you can see that I was programming shell when I was a kid, so I still do it. And I've learned so much by running those pre-commit checks on shell scripts about the good practices of how to use shell. It's amazing. So this shell check is a fantastic tool. Linting Docker file, running mypy, pylint, flake, whatever you can imagine, and few other things, including last week I developed regex, the first regex which I'm actually proud of. It was a regex that checks in our Python 2 version of old versions of Airflow if there are no Python 3 syntax in the files, because I found that there is no ready-to-use tool that you can use very easily, and it takes milliseconds to run it on the whole code base. Yeah? It's like super easy way of making sure that you are not committing Python 3 code into your Python 2 compatible version. And it promotes good practices because this all code runs automatically on Travis as well. So you don't have to write any other checks. You can run pre-commits on Travis. And this is possible thanks to these changes that I implemented, because we now have a consistent development environment. So these Docker files that are shared between the Travis and between every local developer is used actually to run some of those checks. Otherwise, it would be difficult because you would have to have the right virtual environment set, all the external dependencies, etc. We are actually using under the hood Docker images from Breeze to run some of those commits, and that's super cool because it takes very little time. It's super fast. Yeah, so this kind of problems you can see when pre-commit just detects some of the problems that you should fix. What's next? We are migrating out of Travis CI, GitLab CI or GitHub Actions. We are still not decided on that one, but GitLab CI most likely. Kubernetes cluster on Google Kubernetes engine. So Google is a great citizen for open source, and they actually love Airflow because they have Composer, which is Airflow as a service run on Google Compute Platform. And they actually contribute a lot to the whole community. So they even contributed credits on Google Cloud Platform that we can run our tests. We haven't switched yet to that, but as a community, we got free credits from Google, and that's fantastic. Another thing great that Google does, they pay for Google Season of Docs initiative, which is joining technical writers from all over the world and open source projects. And those technical writers have tasks for next 3 months to improve documentation of those open source projects. And Google is paying for that. And we are working as committers and mentors. We are helping those technical writers to write really good documentation, because we are developers. We don't know how to write good documentation, of course, yeah, but there are people who know, who can. And we are working on production optimized Docker images very soon. And that's it. Time for questions.
Do you use stocks for Python version management in your tests, or how do you manage different dependencies, like I don't know, different versions of databases or different backends for Python?
Well, actually, one of the first things that when I started to discuss about changing the environment is like everyone said, let's get rid of docs, and that's what I did. So we had a weird combination of Docker images and docs, but right now we have different Docker image for different Python version, basically, and that's how we manage different Python versions. And for database, we have the same environment, but when we enter the environment, we just set different environment variables to connect to the right database. And the Docker Compose uses starts those databases as separate Docker images, so you connect to either one or the others. They are independent. So like the main Airflow has no knowledge with which the database it connects until the right configuration is set.
Hi, it's Daniel. Do you maintain Kubernetes operators for Airflow?
So you're asking about the Kubernetes operator that is used to run Airflow on Kubernetes? No, this is maintained by Google, by Google Composer team. And by the way, they recently, like 2 days ago, I think, they released a new documentation how to use it, and it's actually quite well documented. And right now it wasn't. So if you want to use it, yes, please use it. But it's not. It's totally done by the Google Composer team. We are not Google team. We are, we are working with them. We are partners with Google, but no, we are not part of the Composer team. There are no more questions. One more thing, because the goal was really to bring more contributors to Airflow. So if you want to contribute to Airflow, feel free. There is a very active community. It's very easy to use it, actually, to start developing Airflow. It's a breeze. Honestly, it's a breeze to develop Airflow, so I really recommend you start doing that. And that's something that I've learned, because I gave already several talks of several versions of that talk, which is like progressing as we implement it. So last time when I did it in New York, I've heard many comments that people are using Airflow are actually developing a lot of operators, but never contributing them because it's so damn difficult. Now it's easy. So if you are doing that, if you are developing Airflow, please contribute. We have a lot of committers. We have 2 more committers now, today. As of today, the 2 new committers were announced. And we will try to review and approve your code as quickly as possible.